purchased for $800 a solar generator and a solar panel in order to keep my refrigerator from thawing during a blackout. Unfortunately, I didn't realize how this would not work. And so the purpose of the video is to go through the analysis so that you can properly size a solar panel and generator to fit your needs. Here's the testing we did. So the solar generator, let's talk about that for a minute. It's simply a battery with a inverter and some interfaces for that. It was a 1260 watt hour battery with a 400 watt input maximum. The solar panel was 2 foot by 7 foot, and pretty much all solar panels are about the same efficiency. So here's the analysis. We ran it on a sunny day in Los Angeles, late September, and a partly cloudy day, the same location, about the same time frame. In the sunny day, we had almost 1200 watt hours collected in the battery, and on a cloudy day, we had 750 watt hours collected in the battery. Between watts and watt hours, watts represents the power for 1 hour. So a 60 watt light bulb would take 60 watts of energy to run that light bulb for 1 hour. And watt hours is simply the length of time that it runs versus the watts. So in this case, you see I ran between 9 and 10:20. I averaged 101 watt hours. It's an hour and 20 minutes. So hour and 20 minutes times the average number of watts is how I got to the 101. So you can see there's a great difference. We're going to focus in on a cloudy day for the rest of the analysis. First thing you have to do for sizing is figure out exactly what appliance you're going to try to run and what your total load is going to be. And you're going to need to know what the watts are for each of your things. You can Google this, or you can go find a watt meter on Amazon for about $15. You plug it into the wall, then you plug your appliance into that, and it gives you how many watts it's drawing. Multiply that by the number of hours you want it to run, and you get a, in this case, I came up with 3,800 watt hours, 3,000 watt hours just to run that refrigerator for 1 day, 24-hour period. So to cut to the chase, for $130, you can actually buy a gas-powered portable generator for which would give you 800 watts, 800 running watts each hour. And you compare that to this 274 number, which is all these added up except for the 110 at night. So 274 is far less than half of the 800 running watts. So you can solve the problem for $130 versus the $800 that I spent that didn't solve the problem. So that's the bottom line on this. Basically, in order to get to 4,000 watt hours, you'd have to spend about $5,000 on panels and solar generators to get there. So it's not going to work for an emergency situation. It's more of a long-term solution than it is a emergency solution. The rest of the video, I'll go through the analysis to understand how to properly size it. I'll do a little product review and take it to the extreme, and then you can kind of see how the whole thing worked out. So here I went in and looked at how many panels I would need if I only got 750 per day versus 1163 per day, and that's when I found out the importance of your input watts on your solar generator. So this solar generator only allowed 400 watts input, which means I couldn't use any more than 3 panels because 5 panels would not add more energy to the battery. Next thing I looked at was, okay, well, what would 3 panels give me? And so the answer was 2,100 watts. And that's by tripling the numbers we had for the early part of the day and the later part of the day. And the main sun part of the day gets capped at 400 because of the input voltage, input wattage. And this would cost $1,200. And then the last thing we did was we said, okay, what would it take to actually solve the problem with a solar generator? And this is what we came up with. It was 400 watt panels. These are 4 foot tall as opposed to 2 foot tall by the same length, about 8 feet. And here we would get almost 4,100 watt hours. And these 4,100 watt hours were limited. The panels would actually deliver 45, but the solar generator I picked would only hold up to 41. So that's what got us at 41. And here you can see the total cost would be $5,000. And it's 115 pounds. It comes with 2 wheels. I actually call out the model here. So the rest of the video, I'll just go show you, do a product review of the solar generator and the panels, and talk a little bit more about getting a gas-powered generator to solve this problem. Make sure it's a dual fuel, and because you really don't want to run gas in it, it'll gum it up. And or you can use, that way you can use propane, or you could use natural gas. They have tri-fuel ones. And my neighbor even puts aviation fuel in his from a small airport near us. He goes and gets it for $6 a gallon, and he can keep that in a 5-gallon tank and store it for as long as he wants. And if you really did want to put $5,000 in, for half that amount of money, you could have a new electrical service panel with a plug that would go to a generator that you keep in your garage. And if you did have problems generating electricity or getting electricity from your power company, you can roll it out, hook it up to your electric panel, and power the entire house with probably no more than a 10,000 watt running watt generator. The video is going to continue with evaluating the solar equipment, and so if you'd like to see that, stay tuned.
So you really need a lot of room to place a solar panel, because you have to keep reorienting the solar panel throughout the day to get the most out of it. And as you can see, I realize now that my backyard is pretty limited in unshaded areas. And although any one spot might work, like for right now I could have it over there, but then when the sun goes down in the west, which is, that wall is a north-south wall, then it can't be there anymore. It needs to be over here somewhere. And then in the morning, to get a easterly view, there really isn't a good view because my house blocks the area, so I have to really have it out front. This is the EcoFlow 1300. It supplies 1,260 watt hours of power. It's got pretty nice, we'll go through the process here with the front. You power the unit on, and then this display will go away, and you can hit this DC power on off to get it to come back up. You can see here it has 34%. It has 34% power at the moment. If you multiply 34% times the 1260, which is full capacity, you get a rough idea how many watt hours you have left. That's more accurate as you get closer to zero, less accurate as you're fully charged. On the back are the inputs. So you have an overload protection reset button. You have the solar power input or the AC input from your wall unit. On the back, you have ports for a cigarette lighter. Where is it? There we go. Port for cigarette lighter or DC devices. And then if you hit this button, that turns on these ports here. notice that they just put a hole for the grounding lug. So you can only have 3 plugs with grounding lugs. But you could have them on top or bottom because the hole's very big. Inside the box, the most important thing you get is the AC charging cord, which will completely charge this battery in an hour and a half, which is exceptional. We also have a cord for car charging. This particular brand is really good because it has a support for every panel. They also have this nice carrying capability with a strap on either side and the handle, which is very useful because they're not that light. And then it comes with this nice pouch with the cables that come out, and you've got these four types. This is the one I used for the EcoFlow solar generator. I really like this solar panel because it has 4 legs, one for every panel, and that way I can get this panel to look as flat as possible. It'll get the most energy possible out of this setup. So just to demonstrate, you'll see as I lift this up, you'll see the shadow come up, and as I continue to lift it, it'll come back. So now what I'll do is figure out the optimum location for the panel. It looks like it's right about there. I'll put my foot there. Then I'll extend the panel out. And it happens to be perfect. In this configuration, the solar panels are incorrectly oriented. They're pointing west and the sun is in the south. And you can see here is the readings we're getting. So we are at 98% full, and we're picking up 108 watts, which is way better than I thought, even with the wrong orientation. Typically we would get around 160. I'll go fix them and show you what we do. Power has jumped from 108 to 171. So here we are with a 75 watt light bulb now. And you can see the load in the lower right corner is 73, so pretty accurate. We're still pulling 168 watts, and the battery's still at 100%. So this is a pretty good test. Well, I plugged in my refrigerator, and it ran the refrigerator just fine in the same manner you see this. The refrigerator drew about 130 watts running, and at night it drew about 110 watts. Okay, the sun's going down. It's 6:20 p.m. and now you can see some action over here. So now the top number is 20 watts going in. We still have a 75 watt draw by the light, and we're at 99%, and it says it's going to take 25 hours at that rate to recharge the battery. However, the reality is that it's going to turn off later tonight, maybe around 4 p.m. So the bottom line is that these solar generators are pretty good for keeping you with electricity during the day in the bright, I would say between 10 a.m. and 4 p.m. And after that, it's just a matter of how much power is remaining in the battery, and then whatever size load you have, it'll shut off about that time.